Chapter 5, Lesson 3, Probability of Compound Events. Compound events are two or more simple events. A sample space of an event is the set of all of the possible outcomes. Example 1. Use a tree diagram and a chart to show both color and style of a car. Color options are blue, silver, red, and purple. Top options are a hardtop or convertible. You have a blue car with a hard top. You can also have a blue car with a convertible top. You can have the silver car, hard top, silver car, convertible, red car, hard top, red car, convertible. Lastly, a purple car with a hard top and a purple car as a convertible. As you count those, you can see there are eight different outcomes. To make a tree diagram, you put color and top as the two things that you are using, and then your sample space. Colors are blue, silver, red, and purple. The tree diagram, just like branches on a tree, you can have a blue car with a hard top or convertible, silver car with a hard top or convertible, a red car with a hard top or a convertible, and a purple car with a hard top or a convertible. If you count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possible outcomes. 4 colors times the 2 tops equal 8. Your sample space looks just like your table. You have a blue hardtop, blue convertible, silver hardtop, silver convertible, red hardtop, red convertible, and purple hardtop and purple convertible. Do you count those? 1, 2, 3, 4, 5, 6, 7, 8. How many outcomes are possible? That is correct. It is 8. Example number 2. If you toss 3 different coins, what is the probability of getting 3 tails? The 3 coins we're going to use are a quarter, and a dime, and a nickel. On a quarter, you have 2 sides, heads and tails. Your only options when you flip a coin are heads and tails. When you flip a dime, you only have 2 sides, heads and tails. If you flip a head first on the quarter, you could possibly do a head next or a head with a tail. Same thing with the tail on the quarter. You go head and tail. Notice how we're making a tree diagram again. Then with the nickel, same thing, two sides on a coin, but you're coming from the quarter and the dime. So from the dime head, you could be head or tail. And from the dime tail, you could be head or tail. And the last one, the same. Head or tail. Head or tail. So your sample space looks like this. Head, head, head. Head, head, tail. Then head, tail, head, and head, tail, tail. Okay, down to the bottom of the quarter, you have tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. Oh, there goes my clock again. Just to refer back to the questions there at the top, how many outcomes are possible on a quarter? That is correct, 2. How many outcomes are possible for the dime? That is correct, 2. So obviously, how many outcomes are possible for the nickel? 2. So you would think that we would have 2 times 2 times 2 as our possible number of outcomes. 2 times 2 is 4, times 2 is 8. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. 8 possible outcomes. So, the probability of getting 3 tails is equal to 1 out of 8. 1 is the number of favorable over the number of possible. Favorable over possible outcomes. So, the probability of getting 3 tails is 1/8. You remember what that is as a percent? 1/8 was one of the fraction decimal percents you were to memorize at the beginning of the year. It's 12.5%.